Hey students, welcome. This is a video on an introduction to hyperbolic functions. Now, we've all seen standard trig functions, sine, cosine, tangent, all that stuff. We've also seen inverse trig functions in my course, sine inverse, cosine inverse, tangent inverse. Now, today we're going to be learning about somewhat different types of functions. They're a lot less common than sine, cosine, and tangent, but they're called hyperbolic functions. And they do share a lot of properties that are similar or even the same as regular trig functions, but they are actually different functions. So we're going to start with hyperbolic sine. And it looks like it says sine h of x. But the way people read it is they say sinh of x. Okay, and that's the same as hyperbolic sine. Hyperbolic sine. So the formal name for it is hyperbolic sine, but when people read it, they say sinh of x. Okay, and the definition of hyperbolic sine, even though it's called hyperbolic sine, is it's actually in terms of e to the x and e to the negative x. Okay, so sinh of x, this is all on our formula sheet. The formulas from Calculus 1 and Calculus 2. So it's on the last page of our formula sheet under where it says Engineering Maths First Aid Kit, the hyperbolic identities. So here we've got sinh of x equals e to the x minus e to the negative x all over 2. So you can always look these up here in case you forget them. Okay, so it's going to be e to the x minus e to the negative x all over 2. That's hyperbolic sine. Okay, and again, the way you read that is sinh of x. So it's actually just e to the x minus e to the negative x all over 2. And then it turns out that hyperbolic cosine is almost the same thing. So once again, looking at our formula sheet on the 4th page, cosh of x, or hyperbolic cosine of x, is e to the x plus e to the negative x all over 2. So notice, here let me zoom in a little bit. Notice here that cosh and sinh are almost the same function. The only difference is for cosh of x, there's a plus here, so it's plus e to the negative x, whereas for sinh of x, it's minus e to the negative x. But they're almost the same function. Okay, so hyperbolic cosine, and the way people say that is cosh of x is equal to e to the x plus e to the negative x all over 2. Okay. So I don't know why my writing is getting wavy, but okay. Anyway, that should be good. So it's e to the x plus e to the negative x all over 2. So again, it's almost the exact same definition. It's just instead of minus here, it has a plus for cosh. And that one is hyperbolic cosine. Okay, and since you have hyperbolic sine and you have hyperbolic cosine, it makes sense that you would also have hyperbolic tangent. Okay, so hyperbolic tangent is tanh of x, and it turns out that that one is just what you would think it would be. So it's actually sinh of x over cosh of x. And that's also in your formula sheet. Okay, so tanh of x, it looks like it says tan h of x. Again, this h stands for hyperbolic. Tanh of x is going to just be sinh of x over cosh of x. And here, I think you should be able to realize why they're calling them hyperbolic sine, hyperbolic cosine, and hyperbolic tangent. Because remember, with regular trig functions, tangent of x is sine of x over cosine of x. Well, here, hyperbolic tangent is hyperbolic sine over hyperbolic cosine. Okay, but again, we would read this as tangent of x, but the formal name is actually hyperbolic tangent. Now, without going into any details, the reason they're called hyperbolic is hyperbolic functions are a special type of geometry based on hyperbolas. But for us, we're mostly just going to be focusing on, since we're doing Calculus 2, we're going to be focusing on doing simplifying expressions, and then in later videos, I'm going to be doing derivatives and integrals of hyperbolic functions. Okay, but in this video, I just wanted to introduce those functions. And of course, you have the other three functions, which are less common. So if we look at our identities page here, you got sech of x, which is hyperbolic secant. That's 1 over cos of x. Then you have cosec of x. That's 1 over sinh of x. So notice with those are behaving just like the standard trig functions, because remember, secant is 1 over cosine, and cosecant is 1 over sine. Okay, so those should make sense. And then you have coth of x, or hyperbolic cotangent, and just like we expect it to be, that's cos of x over sinh of x, just the same way regular cotangent is cosine of x over sine of x. And of course, coth of x is also equal to 1 over tangent of x. So that also works the same. So hopefully it makes sense why they call them hyperbolic trig functions. Some books call them actually trig functions, trigonometric functions. I don't think our book does, but I'm going to write that down. So some books call these functions hyperbolic trig functions. So hyperbolic trigonometric functions. Okay, and I'm going to put trigonometric in quotes, because technically they aren't trigonometric functions that we're used to, like sine, cosine, and tangent, but they have practically a lot of the same properties, as we've already seen from those identities. But our book just calls them hyperbolic functions, but those mean the same thing. Okay? So for the rest of this video, I'm just going to be doing some examples of simplifying expressions involving hyperbolic functions. Okay, so let's see an example. Example: simplify each expression. Simplify each expression. So for your homework, under your homework that's called Derivatives of Hyperbolic Functions, the first thing you're going to be doing is actually not derivatives, but simplifying expressions, like what I'm doing here. Okay, so for problem number 1, we're going to simplify 10 times cosh, so 10 times cosh of 3 ln of x. 10 times cosh of 3 ln of x. So now there's a lot of ways of simplifying this, but since it's just in terms of cosh, what we want to use here is we want to rewrite cosh in terms of e to the x and e to the negative x. Okay? So here you can think of this really as cosh of u, where u is actually going to be 3 ln of x. Okay, so putting it that way, Maybe that helps a little bit. This is 10 times cosh of u, where u is actually just 3 ln of x. So what's the definition of cosh of u? Well, we said cosh, going back up here, was e to the x plus e to the negative x all over 2. But here, instead of cosh of x, we have cosh of u. So it's going to be e to the u plus e to the negative u all over 2. Okay, and of course we still have a 10 out front. So we're going to have 10 times a quantity, e to the u plus e to the negative u all over 2. Okay, but remember, u is just what I was calling this 3 ln of x, just to make it easier for people to understand. So instead of writing e to the u plus e to the negative u here, we're going to actually rewrite it in terms of 3 ln of x. So it's going to be e to the 3 ln of x plus e to the negative 3 ln of x all over 2. Okay, so we have 10. Well, with the 10 and the 2, we can cancel those out. So we're going to be 10 divided by 2 is 5. So we're going to have a 5 out front. And then we're going to have 5 times e to the u, so that's going to be e to the 3 ln of x, plus e to the negative u, so that's e to the negative 3 ln of x. Okay? And then here, you have to remember how to simplify exponential and logarithmic functions. So remember that e to the x and ln of x are inverse functions. And if you have these 3's, and the 3 and the negative 3, you can actually kind of factor those exponents out to make it easier to simplify. So in other words, for this e to the 3 ln of x, I can bring the 3 out into the exponent. Okay, so we're actually going to have e to the ln of x raised to the 3rd power for the first one. And then for the second one, I can actually bring this negative 3 power also out into the exponent. So if I bring this negative 3 out here, then we're going to have e to the ln of x raised to the negative 3 power. Okay, and you might be wondering, well, why am I bothering to rewrite it this way? So what does this accomplish? Well, just recall, this is from pre-calculus. Hopefully you remember this. Recall that e to the ln of x, well, because they're inverse functions, they just cancel out and you get x. Okay, so e to the ln of x is actually equal to x, because the e and the ln cross out. Okay, so here we can cross out the e and the ln for this first term and for this second term. So all we're going to be left with for each one is going to be x. Okay, so what we've got here is 5 times x cubed plus x to the negative 3. 5 times x cubed plus x to the negative 3. Okay, and then for the x to the negative 3, they generally don't want you to leave it as a negative exponent. So remember, a negative exponent is the same as 1 over the positive exponent. So if I move this x to the negative 3 to the denominator, and I'm also going to distribute the 5, then what we're going to get is we're going to get 5x cubed plus 5 over x cubed. Okay, so I distributed the 5 to each term. And then for the second term, the 5 was in the numerator, but the x to the negative 3 went to the denominator and became x to the positive 3. Remember, with exponents, if you move them over the division bar, that changes the sign of the exponent. Okay, and that's actually our answer. So our answer is going to be 5x cubed plus 5 over x cubed. Pretty cool, huh? So when it's just sinh of x or cosh of x, this is usually the approach you're going to want to take. So like in this problem, we just had cosh. That was really our only hyperbolic function. And so then we used the definition of cosh, which is, of course, on your formula sheet. And then we simplified stuff, basically using stuff from pre-calculus. But if you don't remember that stuff, I'll be going over the different formulas that we use from pre-calculus, just in case you forgot them. Okay. So there's another one in your homework that is very similar to the one we just did. So I'm probably not going to do an example of that one, but that one is actually in terms of sinh instead of cosh. So for your second homework problem, just remember that the definition of sinh is slightly different, but it's almost the same as what we just did. The only difference is if you have sinh of u, it's going to be e to the u minus e to the negative u all over 2. But I think you should be good to do your second homework problem because it's very similar to the one we just did. So you're going to rewrite it in terms of this, then you're going to factor out the exponents, and then you're going to cross out the e and the ln, and then you'll be done. Just like on the one we just did. Okay, so I'm going to go, for my second example, I'm going to do an example that's similar to your third homework problem. Because your second homework problem is almost identical to the one we just did, it's just sinh instead of cosh. Okay, now this next one is a bit trickier. Okay, so what we're going to be doing here is a little bit trickier, but it's kind of going to be the same approach that we used before. So for this one, we have cosh of 4x plus sinh of 4x. Okay, and we want to simplify this. Now you might be wondering, well, why do we have to learn how to simplify these? Well, later on when we're doing derivatives and integrals, sometimes you need to simplify an expression in order to be able to do the derivative or the integral and actually finish it. Okay, so that's why we're learning this. And these functions are important. They show up a lot in engineering and science. They don't show up as much as the regular trig functions like sine, cosine, and tangent, but they still do show up, and they are important functions for certain applications. Okay, so cosh of 4x plus sinh of 4x. So here, once again, you can think of this as cosh of u and then plus sinh of u. Okay, where u is just going to be this expression here, 4x. So if we go ahead and write these in terms of exponentials, then we'll be able to simplify. Okay, so we said cosh of u, going to our formula sheet, cosh of u is e to the u plus e to the negative u all over 2. Okay, so e to the u plus e to the negative u all over 2. That's cosh of u. And then sinh of u, well, let's see. On our formula sheet, sinh of x is e to the x minus e to the negative x all over 2. But here our variable is u instead. So it's going to be e to the u minus e to the negative u all over 2. Okay, so e to the u minus e to the negative u all over 2. Now you might think in this step that you would want to go ahead and plug back in your 4x, but actually you don't even have to do that yet, because here what we really want to do is we want to actually simplify this a little bit more before we plug back in our 4x. So remember u, I'm just calling 4x u here just to make it easier to do the algebra. But we can actually simplify this. And you might be wondering, well, how can we simplify this? Well, we actually have like terms here. So one thing we can do is, since we have a 1/2 for this entire expression, we can just factor the 1/2 out front. And then we're going to be left with e to the u plus e to the negative u plus e to the u minus e to the negative u. Okay, so e to the u plus e to the negative u, that's these first two terms. And then we also have plus e to the u minus e to the negative u. That's the last two terms. And then we have like terms here. So we have e to the u plus e to the u. And then we also have e to the negative u minus e to the negative u. So for the e to the u, e to the u plus e to the u is going to give us 2e to the u. Okay, so we're going to have 2e to the u for the red. And then for the blue, because these are opposite signs, these are just going to cancel out. So e to the negative u minus e to the negative u is 0. Okay, so there we're actually just going to be left with 2e to the u. But we still have a 1/2 out front. Okay, but then the 1/2 and the 2 are going to cancel out. Okay, so the 1/2 and the 2 cancel out. And so we're just going to be left with e to the u. Okay, but you don't want to write your answer in terms of u, because u is just a dummy variable that we plugged in the middle just to make it easier to simplify. We do have to write our answer back in terms of the original variable, which was x. So we let u equal 4x. So here at the end, instead of writing e to the u, I'm going to write e to the 4x. Okay, and then e to the 4x is actually going to be our answer. And that's exactly the answer my math lab got, so we're good there. Okay, so that completes this video. This was just an introduction to hyperbolic functions. And if you need to do more simplifying when you're doing some of your homework for the derivatives or the integrals, don't forget about this formula sheet. It's on your formulas from Calculus 1 and Calculus 2, and it's on the 4th page. And they've got all of these formulas on here. Now, most people will not usually use these, but they can be useful in some situations. So they have basically all of the formulas for trig functions, but here they're for hyperbolic functions, and some of them are the same, other ones are different. For example, you would think that cosine squared plus sine squared equals 1, so you would think that cos squared plus sinh squared would also equal 1. But it turns out that you actually have to subtract there. So cos squared of x minus sinh squared of x equals 1. So that one's a little bit of a surprise. That one's a little bit different because you're subtracting instead of adding. And then some of these other formulas are also similar but not the same as with regular trig functions. And you probably won't use these anytime soon, but I have them all here on your formula sheet. And remember, if you're in a later course and you're wondering, you can always, just print out this formula sheet or keep it on your computer and use it later. Because these are pretty much all of the formulas you would ever need for hyperbolic functions. Okay. All right, thanks for watching.